Let's please put our hands together for the next speaker of the day, Mr. S. Suresh from DCW Ltd. Mr. Suresh has 40 years of experience in chemical engineering, management and troubleshooting in multi-product in chemical and specialty chemical industry. Evaluation of various technologies such as AKZO, GR, Rockwood, UHDE and CEC in project execution and commissioning. All right, all of you. चलो यार ताली बजा दो. चलिए जोरदार तालियों के साथ स्वागत करते हैं मैन्युफैक्चरिंग ऑफ सिंथेटिक आयरन ऑक्साइड पिगमेंट सेशन के लिए मिस्टर एस सुरेश.
Good afternoon, ladies and gentlemen. We thank you, IPCA, for giving us this opportunity to share our experience with all others. We are from DCW, the largest pigment manufacturing company in India. I am Suresh. With me, I have Mr. Shamshuddin, Mr. Srinivasan, and Mr. Robin. And we would like to share our experience in the manufacturing of the pigment. Well, there is no great thing about manufacturing of the pigment, that's right. But then the difference is that we are not going by the normal conventional route, and we have picked one of the toughest route possible, and that is to do it from a recovering waste liquor. And that is why we are here to present you. So I'll go ahead with the presentation. Our mission, vision and commitment. Mission to become a chemical powerhouse, and the focus is on optimization. So there again we want to stress that optimization will be the way forward in the future. Vision to enhance stakeholders' value, and our commitment is for a large customer satisfaction. This is our journey. So we started in 1925 when we took up a soda ash plant, and then in 1959 we put up the caustic soda plant at Sahupuram near Tuticorin, and at that time this was the second largest caustic soda plant in Asia. In 1968 we were the first one to go for a trichloroethylene plant in India, and in 1970 followed we made synthetic rutile and also PVC in India. And in 1986 we changed the name of the company to DCW. Earlier it was Dharangadhara Chemical Works. And in 2010 that was the major turnaround year for us, because at that time we were switching from the standard commodity producer to a specialty producer. We started agreement with Rockwood and also with AVINYA for producing synthetic iron oxide and also for CPVC. And then we commissioned, in 2016, we commissioned the largest synthetic iron oxide plant in India. And in 2017, we also started our CPVC plant, and this was at that time the first plant in India to produce CPVC. And in 22, we doubled the capacity to 20 KT, and in 2024, we further quadrupled the capacity to 50 KT of CPVC. Our value proposition, strategic and locational advantage we had. So we have the port very near to us, and that has become a big boon for us. And then significant scale-up opportunities. Basically, when we started this caustic soda plant, we had a big 2,500 acres with us, and that is now helping us because basically caustic salt is needed. So this is giving us a big leverage to go for future expansions. And third is a value-added chain that we are moving up with the specialty. As I told you that from 2010 we have moved from a standard commodity producer to a specialty producer. And we have self-sufficiency. We have our own power plant, and also we now are generating almost 1/4 of our power is from green power basically. And then we have a diversified application. We have 15 industrial products with us, And then we have 8 decades of experience behind us. We have niche and diversified products. And then we have a planned capital expansion for our future expansion. So business, I've already touched upon all this, so I'll skip it out. So basically, 1939, we started our plant at Dharangadara, a small soda ash plant, and that was the beginning of our story. Then we created a history by going for a chloralkali plant in 1959. As I told you, that was the second largest plant in Asia in those days. That was a big achievement by itself. And then we expanded, modernized, and then we started looking into alternate products. We have an extensive distribution network with across 12 countries in the world. And we have a manufacturing plant today at Gujarat and also in Tamil Nadu. Product basket, we have a specialty chemicals in synthetic iron oxide, chlorinated polyvinyl chloride, basic chemicals, soda ash, caustic soda, PVC. And then intermediate chemicals, we have synthetic rutile, liquid chlorine, hydrochloric acid, and all variety of chemicals. Specialty chemicals, CPVC, SIOP, a part of synthetic rutile, and commodity, basically, we are producing PVC, caustic soda, and soda ash. Synthetic iron oxide. So we are the largest manufacturer of synthetic iron oxide with a capacity of about 20,000, 7,000 metric tons per annum. So we are giving our product for a various range of application from construction, plastics, paper, fertilizers, and other fertilizer composites. Now we come to the story. We were producing synthetic rutile, and we had to manage a leach liquor which is coming out from the synthetic rutile production. Basically, that is rich in iron, but also has a lot of unwanted chemicals, which has a big role in affecting the product of the synthetic iron oxide. So the liquor was an environmentally hazardous, and it was an existential threat for the sustainability of the organization. The conventional method was to treat it with the alkali, say lime or something, and then convert that into solid and then treat it. That's a conventional method. But then we were thinking, why not the other way? Why not we go for a value addition with that? And we started our journey. So the idea was finally to recover and make synthetic iron oxide pigment from this leach liquor. So we employed a technique, precipitation and oxidation process. The liquor was treated to remove the impurities. When I say we treated the impurities, it's a two-way treatment, because the one we really try to minimize or eliminate the trace elements which can be harmful for the pigment, and the second was we cannot do anything about the element per se, and only way to manage, keep it afloat so that we get the final product without the interference of such a element. We had a two-step process. We made a seed was made, and then we had operational technique to convert the seed into a product by growth reactor. We are making yellow and red iron oxide. Yellow, we do it by a slow oxidation process, and red, we do a rapid oxidation and precipitation concurrently. So the technique was exclusively designed for us to make this product, which is little different from the conventional pigment manufacturing facilities deployed elsewhere. Of course, once the pigment is produced, then it is very simple. We do a simple filtration, washing, followed by drying. The salient feature of the product. The building block is from leach liquor. That was a major difference. High and efficient purification of liquor to remove the impurities. The most important thing is our pigment's carbon footprint is the lowest. The conventional, as compared to a conventional process, our carbon footprint will be 30% lesser. So all our client can boast that they have a more environment friendly product with a 30% reduction in the carbon footprint. The conversion of the effluent into a value-added product, and that is what we are doing, which also gives us a very important thing is recovery of critical minerals from waste or the tailings. Sometime before the beginning of this year, January, Government of India has come out with a critical mineral policy, and there are 30 elements, and titanium is also one of them. And how we are going to approach that, the government now is loudly thinking of going for a recovery of the tailings, minerals from the tailing, various minerals from the tailings. The tailing includes all the waste of mine material. The mine material which is considered as a big waste and an issue has been now thought that it will be a very big value addition, and they are working on it. Product meets critical specification of the client, and we were coveted with an award from FICCI for process innovation. This is an award which we received for a process innovation, a truly a remarkable achievement, I would say, because those days I don't think many would have tried to venture this, because the entire project cost was more than 500 crores at that time, and to take a big risk, it is very, very tough one. We have a couple of process patent, one for yellow and one for red with us, and I am very sure that we will be coming out with another patent very shortly. Our product is conformed to CE marking, additional feather in the cap. These are the list of our products. We have 17 shades of red, 3 shades of yellow, 1 shade of orange, and 3 shades of black. We have our catalog right here, so all those people who are interested to know our products, they can take the catalog. Coming soon, we are planning for a value addition to this product. We wanted to go for a micronization. We wanted to have a heat-resistant product, and also for reduced heavy minerals. The product already our product is complying to all European and US standards, and we are now thinking of further refining so that we can go into next value chain. We also produce UTOX. This is again a byproduct which is once upon a time thought was a waste, but then we are making it now as a product. We are getting a buff TiO2. This does not have the white color of 99.9% TiO2, but then it is rich in TiO2 with close to 92% to 94% TiO2, and is a big substitute where we need titanium, but then not to that great whiteness. Thank you for your patience listening, and ready to take any questions. Yes, that's what. I would be happy to share our experience if anybody is having questions on this.
Thanks a lot, Suresh ji. So, in comparison to a calcination route, the precipitation route of manufacturing iron oxide, so when you're saying that you are going for heat-resistant or heat-stable pigments, so is it possible, or you will also go for calcination route after this?
See, we can also go for a calcination route, because we do produce yellow and we have tried a calcination route. But the advantage what we find in our precipitation route is that we were able to control the process just by controlling the temperature, pH, and also the ferrous content. Thereby we were able to get a better product than what we were normally getting by a standard calcination. So the plus is that we have a big advantage. The process gives us a leverage, and the entire color is managed only by the process and not by the finishing.
And this again would be a patented technology, I hope.
Thank you so much.
Yes, thank you so much.